Hi, my name is Mischa. I work for Cumulus Networks. I'm the SE for EMEA, Europe, Middle East, Africa. And we're probably going to get the prize for the longest title in the schedule. I don't even, what is it? Why Open Networking as the Universal Network Underlay in OpenStack Environment? That's the title. So what I'm going to talk about is indeed open networking. What is it, and why should you care? So, have you heard of OCP? Probably after today, maybe a little bit more people. OCP, yeah, you know me. Okay, cool. So OCP is the Open Compute Project. It was started by Facebook as a way to basically share their data center vision, their data center designs, what they've done to basically get data center efficiency, and to share their knowledge and their experience with the world and the greater good. The nice thing is, after that was founded, other members joined in as well. Cumulus was one of them. EdgeCore, if you've seen the presentation from EdgeCore, they're also in the venue. They're also one of the members. And some of the members are just being part of it, and others also contribute. Cumulus is one of the active contributing members of OCP, as well as EdgeCore. And basically, the whole idea behind OCP is to basically drive innovation, either to shorten the innovation cycle and to basically lower the bar for open networking in general, just sharing, and to basically get more buy-in from what is happening in the server world and now also in the networking world, because that is the whole idea. So maybe if you've seen the announcement from Facebook, they started some time ago, I think it was in 2014, or maybe even before. They came up with their own switch design. They called it a wedge, and they basically threw some CAD design files into the open. They provided it with an OS, so you could basically go to your hardware vendor factory of choice, and you can basically say, okay, print me this switch. Now, that is all good and fine, but not a lot of people have that capacity or funds to do that. So some of the other members, including Cumulus, we started basically taking that concept and building an OS that you can run on switches. So then the other obvious thing is, I'm not Facebook. Why should I care what Facebook is doing? I've got my 20 racks and 20 switches, and that all works fine. The nice thing that came out of what Facebook has been doing is their network design, because they're basically, and it's not just Facebook, right? It's Amazon, it's Google, it's Apple. All these guys, we call them hyperscale or web scale environments. They have a very different philosophy on their network design. Some of the key takeaways from that was that the complete network of all the ones that I just mentioned, Facebook, Amazon, Google, they're all layer 3. Now, when I speak to customers, people tend to be a little bit afraid of layer 3 because it's complicated. Layer 2 is so much easier. You just plug in a cable and it magically works. Layer 3 is a little bit more complicated. However, the fact that when you do run things on layer 3 and you have IP connectivity between your top-of-rack switches and your servers, it scales a lot better. And not only that, it's also a lot more robust from a high availability failover perspective. Another thing is that they wanted to run, as the industry calls it, on merchant silicon, which basically means industry standard hardware, like you find on your servers or your notebooks. You buy a notebook from Dell, HP, doesn't really matter, but you have a choice of operating system that you want to run on that. And the only way that that's possible is that it runs on industry standard hardware. So that was also what Facebook had in mind when they started this. The other thing is that when you're doing things with layer 3 and you're using routing protocols, you have a very easy way of distributing traffic. So they're heavily invested in equal cost multipath. If you're not a networking guy, it basically means you have 4 links or 4 roads, and you equally distribute all your traffic on these 4 roads or links. So you can easily scale out the capacity that you have available. Unlike with layer 2, where you have links in blocking mode or other fun stuff. Then the last 2 are basically key to by using this and key to what was most important for these hyperscale and web scale guys is that easy to manage, easy to automate, and easy to scale. Which means that it needs to have a standard way where you can actually take a device and roll it into your infrastructure without actually thinking about it. So everything needs to be automated. And from a networking perspective, this is quite rocket science. This is quite new. On the server side and VMs, this has happened forever and ever and ever. And the server guys know what needs to be done. Networking guys still log into their console and go show run and do show interface and create an interface and create a VLAN. And they want to be completely away from that. Sorry? Really? Yes. For some people that might be fun. For some people it's their job. In my opinion, if you can automate that, you have more time to do actual fun stuff. But that's just my opinion. It's just an opinion. So a traditional network design, and probably if you've seen a network diagram, this is very typical, right? So you have your racks, you have your top of rack switches, and then they go to an end of row or an aggregate switch. This is a big one, and it has everything connected, and usually you have two, because if one fails, the other one takes over, which basically means that from a capacity perspective, to bring that back, is that if one fails, you potentially lose 50% of your capacity. So and as well, there's a lot of proprietary, quote-unquote, protocols that you need to be aware of. So interconnecting two different networking vendors on layer 2 is usually a nightmare because they do certain spanning tree protocols and the other ones do it differently and they don't follow the RFCs and fun. So what Facebook and the others have been doing, they're moving away from this traditional end-of-row network design to maybe if you've heard the terms, a spine-leaf network design, or a layer 3 cloth design, or a layer 3 fabric design, where you still have your racks, you have your servers, you have your top-of-rack switches, but instead of having these top-of-rack switches connected to two end-of-row or aggregate switches, you connect them to a next level of pretty much the same switch with all of their uplinks. So if you have a typical 10 gig switch or a 1 gig switch with 4 or 6 uplinks, you can actually connect all these different uplinks to different switches, which means that if one of these spine switches fails, you lose 1/4 or 1/6 of your capacity. And because you're doing this on layer 3, the network will just sort itself out. There's no convergence times that you have to keep in mind. It's just layer 3. Packets will be dropped on the line, and it will take a different path. And this is, as it says, horizontally scalable. So as soon as you need to bring up a new rack or multiple racks, you just connect them to your next spine layer, and you're good to go. Of course, the spine switches also have limited capacities in regards to ports. So you can also add another layer of spine switches on top of that, called a super spine, if you really need to. Question: are you required to run a specific vendor server OS these days? Probably not, right? You get server from HP, Dell, dare I say, Supermicro, and you get to pick what OS you run on it. It's either a Linux, flavor of Linux, BSD if you're like me, maybe Windows if you really have to. But you as a customer, you have the choice what you run on your hardware, which is normal these days. It's commodity. The processors are the same. It's an x86 code base or instruction set. Everybody knows how to talk to that, so it's also fairly easy to build a new operating system. On the networking side, however, everything is very much locked. So in the good old days, this was also true for servers. So you go to IBM or HP, and with HP you get HPUX, and with Sun you got Solaris with it, and it was all one system, and you couldn't really do anything with it, only running your applications, obviously. But that actually was opened up by Intel, AMD, Linux was there, and everybody wanted to run Linux. You can now run Linux on your IBM mainframe, I believe. But on the networking side, this is still a very closed system, which means that if you want to get something on the networking, you have to get it from the same vendor. So that is basically what Open Compute, Open Networking is trying to do, is basically opening up that whole network part, the switching part. Because before, as I mentioned, you get the hardware, the OS, and all the applications from the same vendor. And with applications, I mean the way to monitor, the way to troubleshoot, the way to automate or orchestrate. But it all came from a single vendor. Now what we're seeing is with open networking is you have a choice of hardware, the same with Dell, HP, the same as you have on the server side, you now also have on the networking side. And then on top of that, there's different network operating systems. So I'm from Cumulus, we build one, but there's also Big Switch, there's PK8, there's IP Infusion, and they all have their own specific angle on what they're trying to do. We're very focused on the data center specifically. Big Switch, there's a session, I think now, and they're talking about OpenFlow, I believe. And then on top of that, because we take the open networking quite extreme, on top of that, you get to choose what applications you run on your switch from a monitoring perspective, troubleshooting perspective, and automation orchestration perspective. So that would then basically look like this. So you get your hardware, also from, even more important, also from an optic perspective. We're completely agnostic in regards to open networking. So you can still take your Cisco optic and put it in an open networking switch and it will work. Especially Cumulus, we will support that optic. If it's not on our tested optic list, we will work with you to make it work. And then you have Cumulus as your network operating system, and then this whole nice ecosystem of overlay networks, automation, orchestration tools, monitoring tools, and it all just works. So what is open networking and why should you care? Now, probably if you're using OpenStack, you already, and I think, Andy, you mentioned it in your talk, right? You want to have that choice already. So if you're looking at OpenStack and not VMware, you want to have a choice of your hardware and your software and the plugins that you pick and choose from the nice menu of what is OpenStack. But you want to have that choice and you want to have that control. You don't really want to be dictated by a vendor that says you have to do it our way or it will not work. Probably. So traditional networking, you can compare it to a chair that you buy, maybe not an IKEA chair because you have to still do it yourself, but it's specialized hardware, it's purposely built software, it's tightly coupled, and in most cases there's a, depending a little bit on the vendor, obviously, there's a slow innovation cycle. Maybe not so much on features, if it's a really important one, but maybe on bug fixes, where the vendor says, yeah, next year Christmas, if you're lucky. What open networking is commodity hardware, open software, especially in the case of Cumulus networks. We really evangelize the openness of our platform. Loosely coupled, or I would actually say decoupled to an extent, so okay, loosely coupled, and faster innovation. Because these guys, the only thing they have to worry about, as well as us, is just the operating system, not the underlying hardware. The underlying hardware is already there, it has certain features, and the differentiator is actually in the software. So the software decides what you are able to do with it, with the exact same hardware. So who is actually using open networking in a lot of cases? What we're seeing is it's the traditional, the DevOps guys, right? So you have the dev guy that is a little bit weird, the ops guy that just yells a lot in emergencies, and now you bunch them together, especially when you have organizations that have a server team, networking team, and everybody does a little bit of operation, a little bit of development. I personally think it's a good way of doing it, because then you never have a developer that doesn't know how to actually maintain that in operation. So you get this nice thing going. But what actually came out of the whole DevOps thing is that automation, right? On the server side, automation has been there for a number of years. It works. You have Puppet and Chef and Ansible and SaltStack and CF Engine. The tricky part with automation or scripting in general is that there's always this learning curve, as you can see here. So you have, there's supposed to be geek there, that does it manually, gets annoyed, wants to script it so he can do other stuff, fun stuff. Writes a script, fails, writes it again, and then success, right? And then you have the traditional guys, I wouldn't really say non-geek, but traditional network administrators that are very happy with what they're doing. They don't like automation because they want to keep their job, potentially. But in the end, this will basically limit innovation. Not just on the networking side, because how much innovation can you have on the network, but innovation of what you can do on your network. The reason why you're probably looking at OpenStack is that you can spin up new services or new machines very, very quickly. But if you're still in this non-geek mode, the network will basically be lagging behind. So one way of fixing that is also to look at automation, provisioning, and orchestration tools, the same as you're using on the server side, and now migrate them to your switch side. So, as soon as we start talking about open networking, I always get yes, but support, or yes, but hardware. So let's clear this. All these switches from all these vendors are all running on the same commodity Broadcom chipset, which is basically the heart of a switch. So regardless if you're taking a Cisco Nexus or an Arista or a Juniper or an Extreme, if people still buy that, or an HP or a Dell, it still has the same chipset. So from a packets per second, latency, table sizes, it's exactly the same. The only difference is actually how you program that hardware. So if you like the Cisco way of doing that, go ahead. If you like the Juniper way, go ahead. If you like to have a little bit more choice of the hardware and software that you run on top of your network infrastructure, then have a look at open networking. So I mentioned the leaf spine switch. This is just a typical leaf switch that we see these days, even though there's also a lot of leaf switches that, or customers that are still running on 1 gig, obviously. But a typical leaf switch will have 48 1 gig, 10 gig ports, 4 ports or 6 ports, 40 gig. And a typical spine switch has 32 40 gig or 100 gig ports. The nice thing, what I really like about especially the 100 gig is that you can actually break out these ports. So with the 40 gig, of course, you can do that. You can have 4 10 gig ports coming out. But with the 10 gig, with the new Broadcom Tomahawk chipset, is that you can have 4 programmable lanes coming out of your port, which means either 4 times 10, maybe a little bit of waste, 4 times 25, 2 times 50, or 1 times 100. So you're also very flexible, and you can actually do that with every single port. So you're very flexible of the amount of ports that you're getting out of a single 1U device. So as an aggregation spine switch, this is actually very, very useful. So I've talked a lot about open networking, open compute, but I'm here for Cumulus Networks, and what is it that we actually do? We've created Cumulus Linux, and it's not a Linux-based OS, but we're a Debian-based OS. We're a Linux distribution, which is very different from what, for example, Arista is doing, which is Linux-based. Even Nexus OS is Linux-based. But they actually decide of the level of access that you get to the underlying Linux. With us, you just get a bash prompt and have fun. So that can be a little bit daunting if you're very much in love with the closed CLI of specific vendors that you usually use. Oops, sorry. But the benefit is that it's just Linux. You can actually operate it as your server, which means that since we are Debian-based, you can point it to a Debian repository and install any packages that you think are necessary to run on your switching environment. Of course, we package everything up for the things that we require in order to operate our OS as a switch. So from a layer 2 perspective, VLAN perspective, ACLs, IP tables, EB tables, creating bridges, creating VXLANs, everything is already there. So you don't have to install anything in order to get going with Cumulus Linux as your switch. And basically what we're doing is that all these programs, these userland programs or daemons, so for example for routing we use Quagga as an example. If you don't like it, don't use it, install something else, you can. The nice thing is that all these different programs are just using standard Linux kernel calls, which means that if you want to develop something on your own, you can. We even have a customer in France that thought it was a good idea to build their own MPLS engine on our platform, which they did. Because it's just, they're looking at the Linux kernel API, know what to do from a networking perspective, and they can just build it if you want. You don't have to. And these Linux kernel calls are basically intercepted by another userland program called switchd, which we created to basically program the actual switching hardware. Because the kernel would normally program just your interface card, which is one, which is not really enough. So switchd takes care of the translation of what you've done with your Linux programs and your Linux configurations and translates that to something that the actual hardware understands. And this is a two-way communication, right? So if you want to get statistics from your interfaces, you can. Counters, errors, multicast, whatever. As I mentioned, we're a distribution, so we have our own packages that we package everything up with within our installation. Since we are just Linux, we can also just ship with all the scripting languages that you need from an automation perspective or a monitoring perspective, if you will. Of course, there's some add-ons that we don't really control, but that we package up. Things like Puppet Agent or Chef Agent, or, for example, collectd from a monitoring perspective. And as I mentioned, you can just point it to a Debian repository and install whatever you want. If you want Munin, for example, to do monitoring, or you have written your own monitoring agent or script, just run it, no problem. So, a little bit on the open networking takeaways. The whole idea behind open networking, the fact that you have choice, but also the fact that you probably want to start spending less on your network infrastructure. We see that a lot of customers are moving from 1 gig to 10 gig, look at the price list of one of the incumbent vendors, and they go, whoa, that's a lot. What open networking tries to do as well is to have a more reasonable price for the switches that you buy, so either 10 gig or 40 gig or 100 gig, and basically deploy with that. Now also from the OpEx side, automation for the win. If you can do a lot more with less people, or a lot more infrastructure with less people, that basically means you have cycles to spend elsewhere. So you're basically saving a lot from an operational perspective. And what we also see is that there's a lot of computer guys there, or computer science majors, or whatever the equivalent is, that get a lot more Linux experience. So the fact that you now have your network infrastructure and your server infrastructure, usually there's a lot more, or there's a lot of Linux experience already, which makes it easy for not only open networking, but also to adapt and to use Cumulus Linux. And the whole idea, of course, is that it keeps your business moving forward. From a CapEx savings perspective, OpEx savings perspective, but more from an innovation perspective. The fact that automation becomes more important, not only on the server side, but especially on the networking side, because now it's a little bit lagging behind, which basically means there's no delay to just roll out the stuff that you want. If you can deploy an OpenStack environment in a question of minutes, why not expect the same from your network environment? I like this last one. Linux has become the lingua franca of modern data centers, which basically means it's a common language within a data center. Yes, there's Windows, and yes, there's other flavors of OSs, but they usually run on top of something that actually runs Linux. So what we tend to see is that either from a hobby perspective or even from a production perspective, the customers that we tend to talk to usually have already a lot of Linux skills there. It might not be on the networking side, that's a whole different thing, but on the server side, most definitely. So, are you ready for open networking? If you're deploying OpenStack, you probably are, which means You've already made a choice to not go with someone like VMware, where they tell you you have to do this and in this way. So you already had to make a conscious decision to actually have something else. And with open networking, you can also have something else that fits really well with the philosophy and the structure of OpenStack. And I mentioned it before, automation, automation, automation. It's very, very important from a networking perspective. One thing that we do is, there's always this gap when you get a switch, you turn it on, and before you can hook it up to your network, you have to do stuff on the console. You have to hook up your console, you have to create accounts, create a management VLAN, add IPs, maybe point it to a DNS or an NTP server, and then you can ship it to the data center and rack it and stack it. One thing that we've done, and Arista have done this as well, is that gap we've basically automated as well, so that you can just ship all your switches to a data center. It will start broadcasting on the network, on the management network. Hey, I'm a new switch. Give me an OS, give me a configuration, and then once that is done, you can basically take over with your day-to-day operation tools. So either your Puppet or your Chef or your Ansible or whatever. But that piece, especially from the data center of now, is very important, so that you don't have to ship your switches to your office, configure them, make sure that they take the right switch and put them in the right rack, because otherwise the IPs doesn't really map anymore. Just ship everything to the data center and do everything remote. So automation is key to new types of data centers, in our opinion. So, some resources from our side. We have validated design guides on our website for OpenStack, as well as some others. There's a lot of things around automation. We're pretty much automation agnostic. Within Cumulus, everybody has their own favorite, but we're completely automation agnostic. If you're using Puppet, version, whatever, go ahead. If your requirement is Python, a specific version, you can install it, so you're very flexible on integrating this already in an existing infrastructure. We have a remote lab that is actual hardware with servers connected to it, where you can actually replicate an OpenStack environment, as well as a leaf-spine, either layer 2 or layer 3 network. We also have a Cumulus VX, which is our VMware, or not VMware, our virtual instance that can run on KVM, VMware, VirtualBox, Vagrant, the works. And of course, we have technical training that we do, as well as consulting. So go check out our website. And I just want to part with this. Any questions? Everything is clear. Yes? So, yeah, so the question is, can you suggest hardware to try at home, right? Yes. And it has to be hardware? Yes, I think so, for using the switch path, no? Yes, so the VX, we do have a virtual instance. You can test everything from a Cumulus Linux perspective. Of course, it cannot talk to the hardware, because there's no hardware. So if you really want to do anything hardware related, then of course that needs to be a hardware switch. There are some guys from Dell behind you. They can probably help you. So there are some, let's call it low end. I don't like the word low end, but there's some entry-level switches, 1 gig with 10 gig uplinks that can do that. Yeah. Sure. Yes. Almost, yes. Yeah, but so you cannot take an image of no. Put it on a Cisco device and it will work. That would be awesome. No. Yeah, no, Cisco wouldn't. So the question is, does it run on anything? Does it run on Cisco or Juniper hardware? Yes, I would love that to be happening. Cisco, probably not so much. No, so at the moment, so we have what we call a hardware compatibility list on our website. That has 7 different hardware vendors and 29 different hardware platforms validated. The reason why we do that is that from a support perspective, because that becomes then, especially if you run just a random OS, on random hardware, that becomes a key point. So from a support perspective, we support both the software as well as the hardware. So we're not going to say, yeah, it's a hardware problem, go talk to X. Or they say, yeah, it's a software problem, go talk to Cumulus. So currently, we do have a hardware compatibility list from different vendors, different switches, 1 gig, 10 gig, 40 gig. 100 gig is getting very close. And the only reason is that we still have to talk to not only the Broadcom chipset, but also to all the peripheral components. So disk controllers, fans, temperature sensors, and they're very different from vendor to vendor. So we also have to validate those. Now, the good thing is, in the server market, this was the case in the beginning as well. What they did is they created this, let's call it a middleware layer, ACPI, where the hardware basically tells the OS, these are the components, and this is how you talk to them. What we as Cumulus did is, and that's why I say we're a very active member of Open Compute, is we made an extension to ACPI specifically designed for the switching vendors. Everybody's on board. That standard is donated to the Open Compute project, and hopefully in the near future that would be the case. Maybe not Cisco, but hopefully it would be a lot easier to just buy a switch off the street, get an OS, and start running. That's the end game. Yes?
Could you say a little bit more about the OpenStack integration with the...
I could, but we're out of time. Good question. So the reason why I did this song and dance is that our integration is not done yet. We have a community effort for an ML2 driver, but we're currently in the process of actually writing a Cumulus-supported ML2 driver. The reason why it took us a little bit long is that the acceptance of Neutron was a little bit lagging behind. We do have integrations with Anaconda and with Novanet, for example, and of course with all the overlay vendors like Nuage and Midokura, VMware NSX, and things like that. But from a native OpenStack perspective, we're almost there. Thank you for the question. Otherwise, he would have asked it. Anything else? Or do I have to leave? This is the last session, right?
No, one more.
After me? But not in this room. There we go. Sorry? Exactly. Till the bar opens. Anything else? At our stand, obviously. Oh, one thing I forgot to mention. We have the Facebook switch on our stand together with EdgeCore. And we also have some other open networking switches, and we're also there together with Dell. So come to our stand if you have more questions. Thanks.